Every machine has a loss in output and transformer is no exception. The difference between the output and the input will be the losses. In transformers, there are two types of losses: iron or core loss and copper loss. Now, let's look at the iron loss. The iron losses are classified into two types: hysteresis loss and eddy current loss. Hysteresis loss is due to the reversal of magnetization in the transformer core. The AC current flows in the primary and the secondary coils, thus the flux will be alternating too. This reversal of the flux alters the material structure. Now, let's understand a bit about this material structure. Every magnetic material will have small magnets inside it. The magnetic field produced by them will be in a random direction and hence they cancel out each other. These little magnets inside the material are called domains. So, when we pass an electric current through the primary coil, the coil produces the magnetic field. Because of this, domain aligns themselves in a particular direction. As we have an alternating magnetic field, the domain will change its alignment every half a cycle. The additional electric power required to reverse these domains every half a cycle is known as hysteresis loss. The expression for hysteresis loss is WH equals to P multiplied by Bmax to the power 1.6 into F. Bmax is the maximum flux density in the core. F is the frequency of AC current and P is the constant. Now let's move on to eddy current loss. As the core experiences a changing magnetic field, it is capable of producing an EMF by itself. Due to this EMF, a current will be generated in the core. This current is not useful and does not aid our electrical transmission. It is trapped inside the core and unnecessarily increases the heat of the core. This will affect transformers' efficiency. The expression for eddy current loss is given as WE is equal to Q multiplied by Bmax to the power 2 into F to the power 2. Where Bmax is the maximum flux density in the core, F is the frequency of AC current and Q is the constant. To reduce core losses, we use thin laminated sheets made of steel with high silicon content to make a core. Steel laminations reduce the eddy current and silicon steel reduces hysteresis losses. So that is all about core losses or iron losses. Let's move on to another major type of loss, that is copper loss. Both the windings, primary and secondary, are made of copper. They have a small resistance to the flow of current and it gets heated up because of that. So some part of the electrical power will be lost as heat. This is the copper loss in transformer. The copper loss is dependent on the load current. If the load is more, then the current will be more. This will increase the loss. The expression for copper loss is Cu loss is equal to I1 square R1 plus I2 square R2. Here, I1 and I2 are the currents flowing in the primary and the secondary coils. R1 and R2 are the resistances of these coils. So, those are the losses we have in transformer. To sum up, we have learnt about hysteresis loss, which is due to the reversal of magnetization of the core, eddy current loss, which increases the temperature of the core, and finally the copper loss, which are due to primary and secondary coils. In actual transformers, we try to avoid these losses as much as possible because it hurts the efficiency of the transformer. In the next video, we learn about the efficiency of the transformer and understand the factors which increases the efficiency.